Section 4.8, isosceles and equilateral triangles. If you remember back to section 4.1, an isosceles triangle has at least two congruent sides. So that means an equilateral triangle technically can be classified as isosceles, because with three congruent sides, that does mean that it has at least two. Now the congruent sides are called the legs of the triangle. And the legs where they meet form what's called the vertex angle. So where the two legs meet, we have the vertex angle right there. The side opposite the vertex angle is called the base. If you only have two congruent sides, and the base is the non-congruent side to the other two. And then we call those angles down there that the base meets the base angles. So in this diagram here, angle 3 is our vertex angle because that's formed by the two congruent sides. Angles 1 and 2 are then the base angles. So what we're looking at here is we're looking at just a lot of kind of results of that configuration of information with an isosceles triangle. We have the isosceles triangle theorem. We also have the converse. So the isosceles triangle theorem says that if two sides of a triangle are congruent, so AB and AC, then the angles opposite those sides, so opposite angle, those are also congruent. And what that has to do with kind of how triangles, sides, and angles relate to each other. You know, the longer the side of a triangle, the larger the angle opposite that side is. So the smallest side is going to be opposite the smallest angle. So the biggest side is opposite the biggest angle. The smallest side is opposite the smallest angle. So if you have two sides that are the same, it would make sense that the opposite angles are also the same. So in an isosceles triangle, the base angles are congruent to each other. Then we have the converse of the isosceles triangle theorem. If two angles in a triangle are congruent, then the sides opposite them are congruent as well. And then we kind of look at some results of those theorems. So we get into some corollaries. All right, for an equilateral triangle. If a triangle is equilateral, then it's equiangular. Well, if you have AB and AC congruent to each other, well, by the isosceles triangle theorem, angle B is congruent to angle C. And if you have AB congruent to BC, by the isosceles triangle theorem, angle A is congruent to angle C. And if you have AC congruent to BC, by the isosceles triangle theorem, notice how I'm using the same theorem over and over again, that's giving me a corollary. We have angle B congruent to angle A. Well, by some substitution, once you have all those, you have all three angles congruent to each other. You have an equiangular triangle. So that's by the isosceles triangle theorem. And it works down here as well. Angle E is congruent to angle F. That means the sides opposite are congruent. And if angle E is congruent to angle D, then the sides opposite are congruent. And now you have three congruent sides. So isosceles triangles, that configuration of information, what we get from it, the isosceles triangle theorem and the converse, leading into these two corollaries that relate equilateral and equiangular triangles to each other.